how to use a C language to program an embedded system. This is Sena Sabah, lecturer from University of Information Technology and Communication. Welcome to the third lecture of embedded system course. Keep watching. In this lecture, we will explain the basic of C programming language. Also, we will explain what happens when you click the upload button of the Arduino IDE, what is the compilation process, what the difference between the compilation and interpreter. All this information, all this thing will be explained in this lecture.
In the previous lecture, we explained about the organization of an embedded system. We talk about the core of an embedded system, microcontroller, microprocessor, FPGA, application specific, and the system requirement, how we can choose our microcontroller. In this lecture, we will look at the software side, the C programming language, how we can use C language to program embedded system. Also, we will explain about how the program is processed before it can be uploaded to the microcontroller, about the classes also, and finally the program design techniques, some program design techniques. So this is our objective in this lecture. The code you write for an embedded system, it will not process on the microcontroller. It is not executed directly. Microcontroller doesn't understand C or C++, Java, Python, or any of those language that most human program with. The microcontroller cannot understand what this expression, what if or loop or print. It can't understand this language, this high-level language cannot be understood by the microcontroller. Instead of that, it understands its own machine language. The microprocessor, a microcontroller, understands its own machine language. The pair of hexadecimal, 0 and 1 language. The Intel has its own machine language. ARM processor has its own machine language, and the AVR microprocessor, which we will use in Arduino, it has its own machine language. While in programmer side, we code in high-level language, but that's not what actually executed. So we write a program, a code with high-level language, but it will not execute it directly. It must convert it to a machine code, to a machine language for that specific microcontroller. Then we can execute it. So we write the code, we translate the code to a machine code, then we can execute that code. So one more time, the microcontroller cannot understand the high-level language we use to program the microcontroller. This language, high-level language, must be translated, must be converted to the machine language for that microcontroller. Each microprocessor, each microcontroller understands its own machine language, which is a pair of pairs of hexadecimal, 0 and 1. How we can convert the high-level language to a machine language? We use compilation or interpretation. So what is the difference between compilation and interpretation? High-level language can be translated either by compilation or interpretation, depending on the language we are using. For example, if you use C or C++, you must have a compiler and you must have compiled this language to translate it from high-level language to the machine code. If you use Python, Visual Basic, you will use interpreter to translate the language from high-level language to the machine code. Compilation is the translation from the high-level language to the machine code, the executable file. When you write a file, it cannot be executed directly. It must translate it to the machine code. The machine code, it will be the executable file. That in compilation, you do this process one time just before running the code. So compilation is the translation from high-level language to the low-level language once before running the code. You do compilation, you compile the code only one time. This executable, which is the machine code, we call it executable because it what will be executed in your microcontroller is what it runs every time you run the code. So you compile the code once, you get the executable, and you will use it every time you run the code. So you compile just one time, and you use this executable every time you run the code. C++, partially Java is compilation programming language. In Arduino, which is basically C, you use Arduino language, but it's based on C++ language. So we will use compilation process. We compile once, then we never compile it again, unless we change the program or we find some error and we want to fix that error, you have to compile it again. But when you compile it, when it works, you don't have to compile it again, only you can run it every time you want to use it. On the other hand, we have the interpretation. The interpretation is the translation to the machine code, and it happened every time you run the code. The code should be converted to the machine code every time we execute it, unlike the compilation when you must do it just one time. Visual Basic, Python is an interpretive language. These languages are slow because each time you write the code, you must compile it. But on the other hand, it have its advantage. The program doesn't have to deal with every detail. For example, you don't have to declare variable before you can use it. The interpretation do some work for the programmer. It's more easy to program. Every process, every type has its advantage and disadvantage. So why C language in an embedded system? Why we choose C language? High-level language allow people to program without to know the hardware details. Program become faster, more easier when using high-level language. But on the downside, when we don't know everything about the hardware, everything about the high-level language instruction into machine code and their corresponding use to the function, the program has in effect lose the ability to use the hardware in most efficient way. But the high-level language allow the programmer to program without having no of hardware. Its downside, the programmer lost ability to use the hardware in most efficient way. So why we use the C language? It allows the programmer to manipulate memory location with very overhead added, with very work on the programmer. It can manipulate the memory. It's very good for embedded programming. Also, C will also allow programming to control input-output unit directly. Ease of software reuse. You can just change something in software and you can use it. and it's faster than other language Python. Why? Because in C language you use compilation, you compile the program once, while the Python is an interpretation language. You must interpret every time you use the code, so the C is much faster. On the other hand, we have assembly language. You can use assembly language for embedded system, but you must do more work. You must have very appropriate knowledge in assembly language and hardware architecture. In this course, we will use C language to program the embedded system. We will not use the assembly language. We will only focus on the C programming language. So, what is C cross-compilation? As I said, we will use the C language. The C language use compilation. In embedded system, in our course, we will use C cross-compilation. So what is the C cross-compilation? What is the difference between C cross-compilation and C compilers, other C compilers? Compiler is a program developed to translate high-level language source to the machine source of interest. The microcontroller only understands the machine code. The term cross-compiler, which is what we will do in this course, is the compilation of code in one machine to be used for other machine. What I mean by this? So we will compile the code in the desktop, in the laptop. You will use, in this course, we will use the IDE, the Arduino IDE, to compile the code. We will use the desktop, our PC, our desktop, to compile the code. But the code you get from the compilation, it will be executed on the Arduino, on the AVR at Mega 328 processor. So the compile the program on an Intel processor. The PC has Intel processor. Then we take the result of the compilation. We use the machine code produced from this compilation. We use it for other processor, the AVR processor, a different processor. So the cross compiler is the process of compilation in one machine to use the target is another machine. In our course, we will compiler an Intel processor in our PC for an AVR processor. This is very important. This is very important to understand what the C cross compilation. One more time, C cross compilation is the compilation of the code in one machine to be used on the other machine. In the course, we will compile the program in our PC on Intel processor to use it for AVR processor, the Arduino microcontroller. And if we try to run this executable on Intel, it doesn't work. Okay? The course compilation is very important. You should all be aware for it. Now, we will explain the software toolchain. What is the software toolchain? We will divide this into two parts. The first part we will explain the software toolchain in general, while the second part we will explain the software toolchain on the Arduino. So the first part, what is software toolchain? Software toolchain is the description of the sequence of software tool that you have to use in order to convert the program, the source code, into an executable program, machine code, for the target platform. So the software toolchain is all the sequence of software tool you have to use to convert the program, the high-level program, the source code, the C language, to an executable program, which is the machine code for the target platform. What I mean by the target platform, which microcontroller? Because you have machine code for AVR microcontroller different from the machine code for ARM microcontroller, and so on. This term, the software toolchain, is used in embedded system a lot. So you must be aware about the software toolchain in general in embedded system, and you have to know everything about the software toolchain of the Arduino. Here we explain the software toolchain on general. For example, you write your own code on your PC. You write your source code in high-level language, for example, C or Java or C++. You use cross-compiler. What I mean about cross-compiler is the compilation on other machine to be executed on another machine. So you compile the code on your PC while it will be executed on a microcontroller. Okay, first you write your source code, cross-compile. As a result of the cross-compile, you will get an assembly code. You will use assembler to transfer this assembly code to an object file, which is the machine code related to your microcontroller. For example, the machine code for AVR, or the machine code for Intel, the machine code for ARM processor, and so on. Then after you get the machine code, you must combine your machine code with the libraries. As you see in our lab, when you use temperature humidity sensor, we use some library, the temperature humidity library, we use the LCD library, and so on. So we use the linker. This is all inside. The programmer don't know what happened inside, but when you click the compiler or the upload button, it all will be happened. You will convert from source code to assembly code, then from assembly code to the machine code. Then you must link your machine code to the system library. Then finally you will get the executable code. You will get the executable code. So the linker take the library code, the system library code, and insert it to your machine code. It create link between your code and the library code. This linker will create link between the machine code and the library code. When you get the executable, the programmer will write that executable on the microcontroller. The programmer will write that executable code to the flash memory of the microcontroller using USB cable. This is software toolchain of an embedded system in general. Now we will explain the software toolchain on the Atmega, on the Arduino, on the Atmega 328 microcontroller. When you click on verify or on upload, what will happen? This is a very important topic. You as an engineer must understand what's going behind the scene. When you click on verify or on upload, first your code.ino, you wrote this code on Arduino platform. First it will combine with the main, the hash include, etc. Then AVR/GCC is recall to cross-compile the code. So the cross-compiler on Arduino is AVR/GCC. When you click on verify or upload, you must compile your code. This compilation process is done by the AVR/GCC. This is used by your Atmega microcontroller. Then after the compilation, after the AVR/GCC compile your code, cross-compiler your code, you will get a machine code for AVR. Then the AVR/GCC will link, the linker of the AVR/GCC will link this machine code with the system library you use. Then you will get executable code .elf. Then you will get .elf executable file. The problem with the Arduino doesn't understand, this is understand, the Arduino doesn't understand ELF file. It must be converted to .hex. The Arduino understand .hex. So the AVR object copy is recalled to change the format of executable. So AVR object copy will change the executable file from ELF to .hex. After that, the AVR dude will write your code to the Atmega 328 of the Arduino. This is the microcontroller of your Arduino. So the toolchain of the Arduino, first you write the code in high level language, the C language. You use your Arduino IDE. Then you will cross-compiler the code on your PC by calling AVR GCC. Then you get the machine code. The machine code will combine with the system library using AVR GCC linker. Then you will get executable code. But the problem is the executable code is in ELF extension. Arduino does not understand ELF, so it will recall AVR object copy to convert the ELF on hexa. All these operations will happen on your PC. And finally, you will use AVR dude to write your executable .hex file to your Atmega microcontroller. So we explain about the toolchain in general. We explain about the toolchain in Arduino and on AVR microcontroller. We explain about the C language, the compilation, the interpretation. Now we will talk about classes in Arduino language. Arduino using C++ C to write its code with some Arduino library function. C++ is a superset of C, so if everything right in C, it can be compiled with the C++. A class is used in object-oriented programming. It's not a new subject for you. You already took OOP 2 courses last year. OOP is a way for organizing your code, encapsulate your code. For example, you have a very large code, you must to rearrange it, so it will be more easy for you to change the code, to debug the code. So you have to use OOP. It's a way for organizing your code, to group data, function together into a single class. A class can be imagined as a type. For example, the integer, float is all a class. This class has its own number of functions: addition, subtraction, multiplication, and so on. In this course, I will not explain about classes. I will not explain about the basic of C, but this is just a review what the classes is. A classes is a declarate a variable. For example, here we declarate a variable of a specific class, which is circle. Here I declarate a variable called circle. I made a class. This class is called circle. This class has some variable inside it and some function. So this class has some variable and some function. This variable has the radius and the diameter. After I create this class, I simply can call it. When I said circle f, I create an instance of f from class circle. I can simply say f.dime. Then here it must be two parentheses to enter the variable r. So in the class you can create class. This class contain variable and function, and you can call the class you created and its function. Classes are often used in libraries. For example, in Arduino, when you call serial.begin, So this is class. Serial is a class. LCD.begin is also a class. When you said begin, this is a function for this class. LCD begin, this is a function for an LCD. Serial print, this is a function of serial class, and so on. So classes are very important in embedded system. In programming embedded system, it make it easy for you. When I install this LCD library, I don't have to worry about how can I write on LCD or printing some text. LCD has function dot write. We can write on the LCD. In this course, we will not define any classes. We will use the classes already defined in the library. You must need to review your information about C basic C operator, hash define, logical operation, conditional, if, else, switch, loops, function. Chapter 5 of Introduction to Embedded System. This is the textbook we will use in this course. You can find information about the basic of C programming language on chapter 5. I notice when I ask some assignment from you, when I ask you for do some very easy, very basic assignment, I notice that you don't know or you don't use some programming techniques. There are some programming techniques you can use to make your programming operation more easy, more effective, more efficient. Okay, there are a number of challenges when programming an embedded system projects. All you will have its own project. Each one of you will have its own project. So when you program your project, you may be challenged some issue in programming. So you must understand how to design your program, how to be more efficient, to be more easy for you to write your program. So the approach of structuring code and breaking it into understandable feature is very important. You can do that by designing your program using a flowchart, maybe by using PCTO code, or maybe by using function or files. Here I will explain our assignment. In our assignment, I simply asked you to write a program to check if the user enter start on the serial monitor, it should be turn the lid on. This is your assignment. It's very easy, it's very straightforward, but I noticed you faced some issue there. Many of you cannot understand what the program should look like. So in this slide, I will show you how you can design your program, how you can use the flowchart to make the programming more easy. This is the flowchart of your assignment. Every time, please, every time you have to write some code, you have some project, you have some problem, just write a flowchart. It will make the job more easier for you. For example, here, first of all, you must to check if there are any available data on the serial monitor, on the serial buffer. If no, you must keep checking the serial monitor. If no, you must keep checking the serial monitor. Secondly, if you find some data available, you must read your data. Is the data equal to start? Is the user enter start? If no, the lids must be off and you start again. You check for the availability of data. If yes, if the user enter start, you must read the potentiometer, mapping the reading of the potentiometer and on your lid. Then you must wait for 4 seconds. Why the delay? Why you must use a delay function? As I said, the Atmega 328 which we were using in the lab, it performs 16 million operations per second. So if you don't use a delay function, you will not see the lid is on. It will be very fast. You cannot sense it. So you must use a delay function. After that, when you on your lid, you delay 4 seconds, then you start your loop over and over again. The second method, you use it for simplifying your program. You can write a piece-to code. Simply, you take your a pen and piece of paper, and you think what your program should work, how it should work. First, your program must be start. Then you will enter an infinite loop. You should initialize some character. This character will be hold the value that the user will enter on the serial monitor. First, you must check if the serial is available. Is there any data? If yes, you must read that data. You check the data if it's start or not. If yes, you must read the potentiometer, map its value, then write it on the LED. Then delay for a few seconds, then end infinite loop and start it again. In this slide, I only want to demonstrate the importance of organizing your program, of designing your program. You simply can use a flowchart or a piece-to code. This is a very important. Every time I give you an assignment, every time we do some program on the lab, you can simply understand the code by designing your program. There are another way for more complicated program. You can use function or you can use file.
The end of our lecture. I hope everything is clear. Please, any question, any comment, write it down, and I will answer you as soon as I can. Thank you. See you in the next lecture.